Alright, so let's start with this example here. Again, here is a line, and this one's a parabola, and we don't have to have a picture, excuse me, in front of us to be able to do this problem. So we said earlier that if one equation is a straight line, then oftentimes substitution is the best way to go. But also the other thing to notice is anytime one of the equations is already solved for x or y, then you know that substitution is probably going to be that best way to go. So let's take this x squared plus 2x minus 3 and substitute it into the top equation in place of the y. Okay, this is really going to very much mimic the problem that we ended the last video with. So from here, I'm going to tell you go ahead and pause the video here in just a moment, and distribute that negative sign if your pen will go where it's supposed to, and get everything on one side of the equation and a 0 on the other. Factor and solve for x in this case. Once you have your x's, find your y's, however many there are. When you are ready to join me again, turn the video back on. So we have something very similar to what we had in our last example with our 1's and 2's, only -2 for x and +1 for y, or x also. Okay, when we plug them in, and again I used the top equation, but you could plug them in here. -2, for example, would be 4 minus 4, which is 0, minus 3, which is -3. These two shapes also have 2 points of intersection. And you could use Desmos if you wanted to, or your graphing calculator if you wanted to double check things. Alright, so let's look at this one. Here I have a straight line. Here I have, actually it's a rational function that we spend a little bit of time with, but not enough that you should be able to necessarily visualize this in your mind. And so elimination would definitely not work here even if we wanted to try it. So substitution will be our best bet. Okay. If and in the last two examples we did, the nonlinear equation was the one that was already solved for y for us. Okay, here between the two equations, if I'm going to solve one for x or solve one for y, this one will make more of a mess and it will confuse more of you. It's still doable to solve for x or y, but it will be a better path to take if you solve the top equation and use it to substitute into the bottom. So if x times y equals 24, and x looks like 10 minus y, that gives me 10y minus y squared equals 24. Here's my one equation with one letter. It's a quadratic equation, so there will be two solutions. Go ahead and pause the video, solve for y, and then take your y's back to the beginning to solve for x. Okay, so when we solved, we get our y's on one side. We can factor, being careful with our signs, and we get +6 and +4 for y. When we plug in +6 and +4 for y into either of the top two equations, okay, we will find out that x equals 4 goes along with y equals 6, and x equals 6 goes along with y equals 4. Okay, kind of boring, pretty symmetric, but here we are. Also two solutions. Okay, if we move on to a system like this, okay, because we have so many x squareds and y squareds, we know that none of these equations are lines. Now, because we didn't have time to do the part of the book that talks about conic sections, you probably can't even picture what shape these make. This top one is an ellipse and the bottom one's a hyperbola. Now, anytime I have x squareds and y squareds, I don't want to try to solve one of the equations and use substitution here. Okay, because if I were to try to solve this for x, I would have to take the square root of both sides. I would have a big mess under that square root, and I'd have this plus or minus that I'd have to worry about. Anytime that happens, I think, well, substitution is not the path I want to take. Okay. So when I have some nice, I'm going to say symmetric, not that the graphs are symmetric, but the equations are very nice and all the pieces match up nicely, we can use elimination from here. In fact, in this example, my coefficients of my y squared are already set up as opposites. So that means I really can go straight to the adding part. If we add these two equations together, the y squareds are gone, and we have 3x squared equals 12. When I have only x squared terms and constants, I can divide by 3, and I say, well, I can use square roots to help me. If I'm the person who puts the square root into the problem myself, I need to also remember to put the plus or minus in there. Maybe I'll do that so you can see it right in front of you in bright blue. So there's two possible x values. Then I'm going to come up. I like the bottom equation better than the top one. So x squared minus y squared equals 3. And I'm going to plug in the positive 2 first. So if we have 4 minus y squared equals 3, that means negative y squared is negative 1, or y squared is positive 1. And so if we take the square root of both sides, don't forget to put the plus or minus in there. Teeny weeny. Okay. Then we get y equals positive or negative 1. Now understand that we started with one value of x here. We plugged in x equals 2. And when we plugged in x equals 2, we got two different y values out of there. Positive 1 and negative 1. Okay. So now we get to go back and plug in our other value of x, negative 2. And if we take negative 2 squared minus y squared equals 3, negative 2 squared is still a positive 4. And notice we get the same thing that we just had a minute ago. So our y's, again, are plus or minus 1. So x equals negative 2 is what we plugged in. And we got two different y values to attach to that. Positive 1 and negative 1. I know you don't need the plus sign, I just started writing and so it ended up there. These two curves, our two original equations that we are working with, have a total of 4 points of intersection. Okay, if I forget my plus or minus either here or here or here, I might think there are fewer. Okay, but two x's come out of this equation and two y's came out of each of these. 4 total points of intersection. All right, go ahead here in a moment, pause the video, play with this one. Let's agree before we start, so we're not doing a whole bunch of different things at home. Let's go ahead and eliminate the y squareds because there will be fewer preliminary steps before we do that. So eliminate the y squareds, solve for the x, take your x's back to one of the equations and get your y's. Find all those points of intersection, please. Just want to check in with you for a moment. When we multiply both sides of the top equation times negative 2, we add the two new equations together. It gets rid of the x squareds, sorry, the y squareds, and it leaves us with x squareds. But we're to a step where it says x squared equals negative 4. When we're solving a system of equations, a nonlinear system, we don't always get real solutions. We know there will always be two solutions to any quadratic equations, but we know that they don't have to be real numbers. Okay. Our author wants us to find all the solutions, even if they're complex. So think about what those would look like, and then be careful when you plug them back in up here to get your y's. All right, so x is equal to plus or minus 2i when we solve this for x. So we plug in, I'm going to use the top equation, but you could use the bottom if you'd like. We're going to start here and solve for y, and then we'll go back and make this a negative sign and do the same thing. Okay, so it's not a pretty value, but when we plug in 4i squared remember, is equal to -4. So -4 times 2 is -8. We'll add the 8, divide by 4, take the square root, plus or minus. Okay, and I'll come back and write the ordered pairs in a minute. Okay, go ahead and plug in the -2i squared. Pause it. I'm going to jump here in just a minute and have those solutions, so pause it now unless you want to see the end. When we square -2i, we also get positive 4y squared, which is still a -4, which makes this a -8, which means it looks exactly the same as the equation we just solved. So when we used positive 2i, we got square root of 13 over 2. Ooh, sorry, that still says 2i. And negative square root of 13 over 2. When we used negative 2i, we also got those same two solutions, positive and negative square root of 13 over 2. Okay. What your author will write, and it's a nice shorthand way to write it if you're comfortable and understand what it means, is we have all four combinations here, plus or minus 2i, comma, plus or minus square root of 13 over 2. Okay. Next video will, actually, I think maybe that's where we're gonna call it good. Let me know if you need some help.